Hi everybody, and welcome to the first video on loops. Loops are a foundational concept in computer science. They are probably the biggest topic of this course. They are incredibly useful, they are incredibly powerful, and they really are at the heart of computer science. So in this video, I cannot show you how powerful they are or how useful they are because this is just an introductory video, but let me just tell you that by the end of the semester you will be convinced of how powerful they are, especially when you use them in conjunction with other things that we use, such as if statements or later on in the course vectors, things like this. Okay, so this is an introduction to them. So to motivate what they do for you, consider a program like this. You're playing blackjack and the table has a limit of $10,000. So in other words, once you win $10,000, you can't keep playing. The table will only pay out 10 grand. Also, of course, if you go broke, you are done. So we need to somehow translate this English into C++. As long as the user isn't broke and their winnings haven't gone over $10,000, they should be able to keep playing. Okay, so more formally in sort of pseudocode here, this is what we want. As long as the money they have is bigger than zero and their profit hasn't exceeded $10,000, they should be able to keep playing blackjack. So anytime you find yourself using a phrase like as long as or until, you're going to need a loop. Okay, so the word if in English translates to if in C++, right? It's a direct translation. The word otherwise translates as else, right? With if and else statements. The phrase as long as translates to while in C++. So a while loop looks like this. While you have a Boolean statement in here, do this code. So what this translates to in English is as long as, right? The word while means as long as. As long as this statement here is true, then keep doing this code. Keep doing this code over and over and over again. So the code inside the braces will run over and over until this statement here becomes false. Once that statement becomes false, you do what's called breaking out of the loop and you won't do that code anymore. So essentially, a while statement is like an if statement that can repeat itself. So suppose the word if were right here. Then when you got to this line of code, you would see if this is true or not. If it is true, you run this code and then you go to this brace and you're done. If it's not true, you just skip right over it. Okay? With a while statement, if this is false, you also just skip right over it, just like an if. But in contrast to an if statement, if this is true, then you run this code, and when you get to this closing brace right here, you then go and ask, wait, is this statement still true? And if it is, you jump right back up here to the opening brace and run the code again. So loops jump. You get to the end of the loop. If the statement up top is still true, you jump back up to the beginning of the loop and start over again. So here's an example, okay? Oops, I left off a semicolon there. But anyway, so int x equals -1. So the value of x is -1. So this says now, as long as x is less than or equal to 0, we should ask the user, hey, I wanted a positive number. Right now it's not positive, is it? -1. I wanted a positive number, please enter 1, and then we'll grab another number from them. So in contrast to an if statement, if this said if right here, then we would just run this code and we would be done with it. But since you have a while there, what happens when you get to the closing brace is, notice the value of x might be different depending on what the user enters. So now you would check and see if x is still less than or equal to 0. And if it is, you run the loop again. Otherwise, you break out of the loop and keep going. So just to see that in action, here's the compiler. So this is the exact same code. Okay, so enter a positive number, -5. Enter a positive number, -10, -7, -8. Okay, it will keep doing this until I enter a positive number. So now if I enter 4, it says finally, the thing you gave me was 4. Okay, so again, the loop allows you to jump back to a beginning of a chunk of code and do that code over and over and over again until this Boolean statement here becomes false. So what happened when I entered that 4 right there, the value of x is now 4. So when you got to the closing brace, you checked and asked yourself, is 4 less than or equal to 0? Well, it's not, right? The statement 4 less than or equal to 0 is false. So that's when you break out of the loop and you don't do that loop code anymore. So again, it's like the English as long as. Hey man, as long as this is true, you keep running this code. But when it becomes false, you quit. Okay, so here's another example, looping until the user says stop. So you can get a response of 1. And hey, as long as responses run is 1, you can tell them hi. And then you can say, hey, would you like me to say hi to you again? Basically, right? Enter 1 for yes, any other number for no. So then here you grab a response from them. So if they enter the number 1, now we're at the closing brace. Now we go up here and ask ourselves, is response still 1? And if it is, we do this code over again. But if the user entered a 7 or something, 7 is not 1. So you have now made this statement false. So when we get to this closing brace and we check to see if this condition is still true, we see, it's false, and then we stop. Okay, so as I said at the beginning, there are many applications of loops. They are very powerful. Here's one of them, checking that the user gives you something you want. So imagine a code segment where you tell the user, enter 1 for easy, 2 for hard, like in a previous example in a previous video. Well, what if the user doesn't do that? What if they enter a 7 or a 9 or something, right? Well, then what you need is some code that says, hey, as long as they're giving me something invalid, they need to try again, right? Because they can enter a 7, a 10, a 13, whatever. You need to make some code that says, as long as the user's not cooperating, we need to make them try again. So the following is an example of what I call an input validity loop or a validity check loop, something like that. This loop makes sure the program will not continue until the user enters something valid. So if you want either a 1 or a 2, the invalid things are the not of that. So we discussed this in the last video, right? If you want to not an or statement, it becomes an and. So if x is the variable with value 1 or 2, as long as x is not equal to 1, and also x is not equal to 2, so x is a 7 or it's a 10 or something, you tell the user, that's not what I wanted a 1 or a 2, you try again. And then force them to eventually type a 1 or a 2. So let me just put that code here. So let's keep x as -1 right now. And so as long as x is not equal to 1, and also x is not equal to 2, we can tell the user, I don't like what you just gave me. Okay, so invalid input, please try again. And then the code will not keep running until they give you something valid. But then, once the loop stops, you know you got something valid. So now if x equals 1, we can say, okay, easy mode. Otherwise, if x ended up being 2, you can say, okay, hard mode, whatever, right? So let us run this. So it's going to start by telling me invalid because I set x equal to -1. So maybe I'll enter a 6. It says invalid, it wants a 1 or a 2, 8, 4, 6, right, etc. Right, you get the idea. So now if I type a 2, well, now the value of x becomes 2. So we break out of the loop because this statement now becomes false, right? This right here, this substatement is false. 2 not equal to 2 is a false statement. So you've made that false, therefore the overall and is false. So when you break out of the loop, x has value 2. So that's why you enter this branch of code and you say, oh, you chose hard mode. So that's one example of the uses of a loop. You can sort of put these in the code at spots where the user gives you things if you're afraid they might put something invalid in there. So if you think they might not enter a 1 or a 2, you can force them to, or the program just will keep running. Here's something else you might want to do. You want to write a program in which the user enters as many numbers as they want, and then you might want to compute their sum or something. So the point of this example, really, the heart of it is this. So let's say the user is going to give you a bunch of numbers, but you don't know how many. What you can do is use a loop in this way. So let's just walk through this code. I create num and sum. I set sum equal to 0, and then I tell them, give me a number. And when you're done giving me numbers, enter a character. Okay, so the heart of this example is this loop right here. As long as I am cnning a number, so this right here may not look like a Boolean statement, but it is. Number is an integer. So this statement here is true as long as I'm entering integers. But as soon as I enter like a t or something like that that's not an integer, this statement will become false. I will not have cn'd an integer, or I will have cn'd something else. Now, when I go inside the loop, look at what's happening. The sum value is keeping track of what I've entered and adding it. So sum initially is 0, right? So when I enter my first number, the value of sum becomes 0 plus the value of my first number. And then I say, hey, enter a number and give me a non-number character when you're done. Okay, so now I go back up to the top. This statement was still true. I didn't do anything to break this statement. So I can enter another number if I want to, my second number. And now remember the value of sum. The value of sum was your first number. But now you enter a second number, and so now you take the value of the second and add it to sum. So sum is just now your first plus your second. And so on. So the process just iterates. So basically, each pass through the loop, each time the loop runs, you're just tacking on another number to the end of sum via addition. So when the loop is done, it will have added everything together for you. So let's just put that code here. So clear all of this out. It's num. Well, sum I'm saying is 0. Let me just skip the prompt for time. So as long as I'm entering an integer, sum is sum plus num. Another number or character if done. Okay. At the end, I will print whatever the sum was. Okay. So let's run this. Whoops. Rookie mistake. No semicolon. Okay, so I'm going to enter a 10. Another number or character if done, I'll enter 20. Okay, so as long as I'm entering an integer, this statement is still true. So now I could enter maybe another 10 and maybe a 30, etc. Okay, now I'm going to enter a non-number like a D. So entering a D makes the statement false because number here, this num, is not a character, it's an integer. And so what happened was when I entered that first 10, sum became 10 plus 0. Right? So sum initially was 0, and then I add 10 to that. So then when I get to the end of the loop the first time, the value of sum is 10. The next pass through the loop, I gave the number 20. So since the value of sum is now 10, I do the new value of sum is 10 plus 20 for 30, and then just keeps going. So every time I enter a new number, that new number is just appended to the end of what you have already done. So the takeaway from this example is this line of code right here. As long as they're entering a number, you can do things with it. You can calculate a sum of a bunch of stuff or whatever. You can also make a loop run a certain amount of times if you want to. So you can create what's called a counter variable. So counter is 1. As long as counter is less than or equal to 10, do something, it doesn't matter, and then up the value by 1. So notice this loop will run 10 times because counter is initially 1, and 1 is less than or equal to 10, so I'll go in the loop. Then the value of counter becomes 2 at the end of this, right? Well, 2 is still less than or equal to 10, so I'll run the loop again, and the value of counter becomes 3. 3 is less than or equal to 10, etc. So this loop will stop when counter becomes 10, right? Well, 10 is less than or equal to 10. So you'll do the loop, and then counter will get value 11, and then this becomes false, so you will stop. So if you want a certain chunk of code to run a certain number of times, like for whatever reason I want to tell you hi 10 times, you can use a loop to do that. Okay, so let me end this video with a warning, a misuse of loops. Consider this code segment. This is different from the last slide. So if we were in class, I would ask you to tell me the difference to see if you can spot the difference. So this chunk of code ran 10 times. Counter was 1, then it became 2, then it became 3, 4, 5, etc. until it got to 10, and then the loop stopped because then the value became 11 and I break out. Notice the line of code counter plus plus is missing here. So when you're inside the loop, you never update the value of counter, right? So what happens is 1 is less than or equal to 10. I go inside the loop. I run this code. I get to the end of the loop. I check, is this statement still true? Well, yeah, it's still true because I didn't change the value of counter. So then I run this line of code. I then check again, etc. Since the value of counter never changes, this loop will run infinitely many times. That is bad. Presumably, you did not want to create a loop that runs infinitely many times. That's probably a mistake on your part. So just to watch the computer go haywire, let me put that code here. So counter is 1, and as long as counter is less than or equal to 10, tell you hi. Okay, so if I run this, watch what happens. It's going to tell me hi forever. Okay, it keeps going, right? So I'm scrolling to the right. It's kind of hard to tell because it's so symmetric, right? But it's just going to keep printing hi until the computer crashes, unless you tell it to stop running, which I did. I hit the stop button here. So eventually the computer will just run out of memory and quit printing all that. So anyway, so you have to be careful with loops. In general, you should avoid infinite loops because presumably you didn't mean to create one. This chunk of code here presumably was supposed to be something like this, where you break out of the loop. Okay, so at the end of this video, you should have a basic grasp of what a loop is and certain things it can do for you. So it can, be a validation check was one of the main examples. It can let you do things like calculate the sum of a bunch of numbers as the user enters them, right? You don't need to remember what you've seen before. You just take the new number and just append it to the end using the sum variable. But basically the idea, right, is that it's an if statement that can repeat itself. So at the end of a loop, you check and see if this Boolean statement is still true, and if it is, you repeat. But loops come with potential issues, like if you misuse them, you might accidentally create one that runs forever, right? If you create a chunk of code that can run twice, then you've created a chunk of code that could potentially run forever if you don't give it a way to stop running. Okay, so that's the end of the introduction to loops.